Добрый день, уважаемые участники. Меня слышно?
Да.
Окей. Позвольте представить, меня зовут Гульнас, и я работаю в Астана Хаб по направлению развития R&D лабораторий и корпоративных инноваций. В первую очередь благодарим за участие в сегодняшнем вебинаре и напоминаем, что Астана Хаб специально для вас проводит на постоянной основе бесплатные образовательные мероприятия и различные темы сферы IT, направленные на развитие необходимых для вас навыков. Поэтому, чтобы оставаться в курсе всех мероприятий, просим активно следить за аккаунтами Астана Хаб и Corporate Innovation R&D в социальных сетях. Ссылки на них вы можете найти в письме. Сегодня Астана Хаб совместно с Блокчейн лабораторией проводит онлайн-бесплатный мастер-класс на тему Blockchain-based Telecommunications. И перед тем, как начать мастер-класс, просим участников отключить звук и видео и не подключать в течение всего вебинара. Это необходимо для того, чтобы постоянные шумы и образы не отвлекали вас и спикера. Если вы хотите задать вопрос, просим написать его в чате, и к концу вебинара мы уделим минут 10 на ответы и вопросы. Спасибо за внимание, и передаю слово нашему спикеру, и давайте начнем. Let's start.
All right. Excellent.
Okay, thanks.
Thank you. Let me begin sharing my screen. I think you may have to do something on your side so I can.
So it works?
No.
No?
If you can, there's just a setting on the on Zoom to do that.
Okay, just a minute.
Mm-hmm. Right to the right of the share screen button, it's like allow multiple users.
Okay. Can you try?
Yep. Seems to be working
Okay.
now.
Thank you.
Absolutely. Okay. Let me just set this up and we'll go ahead and get started. So thanks very much, everyone, for joining. Today, we're talking about blockchain and its usage within modern telecommunications. And, you know, my name is Mayande Walker. I'm the CEO of OpenCTNet, which is a company here in Nur-Sultan in Kazakhstan. And we're doing some very exciting things, but rather than talking specifically about what we're doing, I'll mention later a little bit about BAT, blockchain as a transport. I'd like to talk about blockchain and telecommunications in a more general sense in terms of, you know, what the challenges are, how blockchain helps. So let's just kind of get into it. So what we're going to talk about today is, number one, what is the promise of blockchain in general? And this sometimes is applicable to many different industries. But then we're going to focus on, you know, how blockchain is typically thought of in relations to telecommunications. What are the challenges in telecommunications? How can blockchain help? And then finally, a little bit about what OpenCTNet is doing today regarding blockchain and telecommunications. So I want this to be, you know, very open-ended. I'm certainly open to questions, and the more interactive for me, the better. But ultimately, perhaps the format is that, you know, I'll give this presentation and there'll be questions afterwards. But I don't know if you're able to. Anyone, if they have questions, feel free to. And so let's just talk a little bit about blockchain and telecommunications. Before I even talk about blockchain, because I wasn't certain of the audience's technical understanding of blockchain in general, I just want to talk about a few things that'll help our conversation in terms of, you know, what is needed in telco. But to begin with, let's just say that, you know, blockchain for those that may not know all the intimate details, is a very new way in which you can support lowering uncertainties in transactions by building a cryptographic framework of trust. What that means is that there's some really cool math and compute power that's used in order to ensure that two parties can transact with each other within a framework where they don't necessarily need to know about each other, but they have the trust that based on the information that's provided and the framework through which it's provided, that they can transact. I have to be honest and say, like many, my introduction to blockchain was the first application, of course, which is Bitcoin. Obviously, there are elements of blockchain technology that are much older than Bitcoin, but like so many others, Bitcoin was my first introduction. And it took me a long time before I came to truly understand its value in terms of what's called decentralization, and in terms of how this could be used in different industries or in different, in different ways. So with Bitcoin being the first application of blockchain, it's very typical that it's often associated with the financial industry. I actually come out of the financial industry, but in building optical networks for very large global companies, and building out very sophisticated optical networks to ensure support for high frequency trading and very top of the line telco services for the high frequency trading industry. And as such, I guess my introduction to blockchain is a little bit unique because I certainly, as an engineer, have looked at it in ways that might be a little bit unique. So, one of my biggest points that I like to share with folks that have any interest in this is that the way in which blockchain can be used, can be very differently than what we think of. So let me explain what I mean. So when we think of blockchain, one of the first things that comes up is the concept of a distributed ledger. So this distributed ledger, we can find trust in this database because this ledger is not owned by any central authority or any one person. And in fact, this is a database that is shared across many, many different computers. And so because in order to change a transaction within that blockchain, you'd have to change it on all computers at once. There's other nuances if we want to talk about a 51% attack, but in general, when we talk about blockchain, it's understood that the power of that distributed ledger is the fact that the records are immutable and that it is incredibly difficult to introduce inaccurate information on that ledger once it's been agreed upon and published across the blockchain. So, the promise of blockchain in general is one in which we can imagine the ability to, lower uncertainties in transactions. I think one of the rather ambitious concepts that comes with blockchain is this idea that it's possible to have a autonomous organization that is truly decentralized. What does that mean? That means that you could have an organization through which there is built upon blockchain a framework of transactional activity. There's a concept called smart contracts where, based on certain parameters, certain activities are triggered. And so if you take this to the nth degree, there's the possibility that you could create a full-fledged organization that doesn't have to have human interaction in the day-to-day decision-making of what that company or organization does, because all of this can be pre-programmed into a smart contract or into a framework that allows this organization to move very quickly and without anything more than the input that's provided that allows for certain transactions to happen. So there's a lot of reasons why this could be attractive, mainly because you definitely can support disintermediation where you don't have lots of folks in between the process of making these decisions. And also, it relates to some other very interesting aspects. I'm going to talk again about how this concept could be meaningful within telco. But in order to do that, we need to talk a little bit more about telecommunications in general and what blockchain, what is thought typically about blockchain within telco. So I want to, just preface this next slide with a little bit of a statement about telecommunications. Everyone has a smartphone, so they imagine that they understand what telecommunications is, right? We all have a smartphone. We have a plan with our cellular provider. We surf the internet. We do a lot of the things that we used to do on computers now on our phones. And we imagine that because that is what we are actually doing through a cellular network, that we have some understanding of what telco is. But I'd like to share that beyond the consumer market, telecommunications is a much, much bigger and broader animal in terms of connectivity solutions, in terms of how that telco is used. And it's important to understand that because the areas that blockchain can help, go well beyond the, cellular or wireless network. So let me just chat a little bit about what is telco beyond what we are most familiar with. So obviously there's many different mechanisms for telecommunications. There is optical, there's good old fashioned copper, there is satellite, there's a whole host of different things that can be used, free space optics, Wi-Fi, WiMAX. But my point is to say, not just that there's different mediums through which telco can be facilitated, but we have to remember that when you are part of a organization, an enterprise, whether it's local, global, a government, the ways in which these organizations operate necessitate the ability to transfer data either from a data center, from a central headquarters to a branch office. And so, when you look at just about any organization, whether it's a hospital, whether it's in healthcare or the financial or anything at all, telecommunications plays an incredibly important role. And certainly in my background in the, high frequency trading arena, telco plays a very important role. So for those that, may be aware or may not be aware, in high finance, there's a particular issue that's called latency. And so when a financial entity that does a lot of trading wants to do large algorithmically based trading at an exchange, they need to have circuits that have incredibly low latency. What does that mean? That means that the time that it takes for me to publish a transaction from point A to point B, my circuit, either because of the shortness of the fiber from point A to point B, or because of the health of that fiber, I can save microseconds, picoseconds. And if my transaction is even, 100 picos or milliseconds faster than my competitor, then I've won, and I can actually get my trade in before they do. So in general, telecommunications goes much farther than just our cell phones. So how is blockchain used today or thought of typically within telco? Well, using the same concept that's been done with the initial applications like Bitcoin, blockchain is often looked at as a decentralized ledger. And so it's thought that it can help with certain aspects, mostly accounting, certain aspects around identity management. When I say accounting, I'm meaning back-end billing processes. So, global carriers have to interoperate with each other. So there's all kinds of arrangements that are made in order to facilitate the ability for their customers to communicate globally. And sometimes the same applies regionally. There are things like fiber swaps, or there's agreements that are made that, you know, my data will cost your network at this point, and so on. And these agreements have a financial value to them. And so it's thought that blockchain can help with that because, again, when you think of it, when you put on the lens of finance and accounting and the concept of a distributed ledger, you think, you know, how can we use that ledger in a meaningful way for greater efficiency? Another area that is typically thought of is supply chain management within telco. So obviously supply chain management is much wider and goes beyond telecommunications. But the point that I really want to make here in talking about how blockchain is typically thought of in relation to telecommunications is that the current mindset is one where the focus is on how can that distributed ledger be used for the telecommunications industry. Now, I have heard of some, you know, there's some folks that are forging ahead, my company included. There's others, T-Mobile, Vodafone, that are looking at things, but still, again, from an accounting standpoint, I'll make that differentiation of our company in a moment. But the most, you know, different thoughts that have arisen with smaller companies is the idea that perhaps you can, on a consumer level, take the mobile minutes that are associated with your plan and you can somehow consolidate those minutes into a new plan that could be, you know, repurposed for someone else. This is similar to the concept of, you know, taking reward points and making them available in a new way to a new audience. Interesting, but I'm here to say that it's a very limited application of blockchain. There's actually a lot more that can be done, and we'll talk in a minute about what some of those things are and how that applies. So let's talk in general about what the challenges are in telecommunications in general. Number one, declining revenue and a history of build it and they will come mentality. Let's talk about that a little. So why would the telecommunications industry be experiencing declining revenue? Well, there are lots of very, very smart companies that have built amazing solutions and applications that are supporting telco in a very innovative way. So we'll start with, you know, one of the biggest ones that made a huge impact in telco, and that's Skype. So Skype is a service that you can download on your laptop or your phone, and it allows you to talk for free using the internet. Groundbreaking, but definitely, you know, impactful in terms of, you know, telco or carriers' abilities to monetize what they want to sell or what the networks that they've built. There are other great examples. WhatsApp is a nice, exciting one. WeChat. You know, there's lots of ways now that consumers are able to communicate with each other, and to a large degree, even enterprise environments are looking to adopt some of these very cool technologies. Right now, we're using Zoom as another great example of a way in which video conferencing can be supported, and it's using the internet, and for all intents and purposes, it's free, you know, aside from the subscription fees. So one of the things that I'd like to kind of point out that has plagued telco and continues to is this mentality of build it and they will come. So what do I mean by that? The biggest commodity within telecommunications is bandwidth. And so what carriers have done is they have built out these long, large, extensive networks in order to facilitate the ability for bandwidth to be available, right? So perhaps, you know, we are here in Nur Sultan, but obviously there are other regions of Kazakhstan that are much more remote, you know, that don't necessarily have the kind of infrastructure that we enjoy here in Nur Sultan. But the point is that the model for how telecommunications have sold bandwidth has always been build it with some, estimate as to what the demand might be, but essentially you spend millions upon millions of dollars to build out this large, long, complex infrastructure. And then you spend the next 5, 10, 20 years looking to monetize what you've built. So this is what's led to an approach of billing where, particularly within the enterprise world, you end up forcing your customers to pay for bandwidth that they may not necessarily need. So in other words, you end up making, if you are the CIO of a large enterprise, you may not necessarily know how much bandwidth you'll need. Today, tomorrow, you ask your analysts, you ask your internal team, but you basically take a guess and you then work with your carrier to support that. And in order to get the best possible pricing, you negotiate long-term lease, essentially, of that bandwidth. So, one of the things that I'd like to share for those that may not be aware is that with all of the smart applications that are being built today, WhatsApp, Zoom, etc., they are leveraging the internet, and they're leveraging it because it's available, because it's distributed, and it allows them to be able to very quickly offer good, reliable services to their customers without the need for building out this large, long, complex, infrastructure that carriers have. So what has that meant for, the tier 1 global providers? I'm going to jump ahead to number 4 for a second. So, tier 1 providers globally often find themselves in a position where, because of all of these hot new, applications that are out there, in order to continue to monetize what they've built, or, they've kind of given up a little bit. They've kind of said to themselves, let's focus on, content provisioning. Let's focus on advertising. Let's find new ways that we can bring revenue into our organization beyond the typical concept of, hey, we're trying to monetize this great, telco infrastructure that we've built out, this build it and they will come mentality. Interesting, but it definitely takes these tier 1 providers away from their core service offering. And at the end of the day, if you are paying a bill for services, you want to ensure that there's value in what you've paid. And that leads right to item number 2. What is it that global enterprises really want? Well, obviously, they want connectivity. They want to know that they can share information and data across their enterprise with all of their offices, all of their headquarters. They want to make sure that in the case of, a global pandemic like we've been undergoing globally, that their workers remotely have the ability to connect back to their offices. They can work remotely and still do all the same services and functions that they do when they're in their offices. So they want bandwidth, and they want the ability to know that they can get value for what they pay, etc. There are some very interesting things that are happening in global enterprises. There's a new technology, fairly new, around 5 to 10 years old, called SD-WAN, that's building or generating a lot of excitement because you're taking the compute power within a platform that can determine, based on various factors, which pipes within your organization should be used for which services. What do I mean by that? We all have, in a global enterprise, you have typically private circuits that are connecting your offices. I'll talk a little bit more about what private circuits are. And then you also have internet connections. And so there's certain times where there's certain data that could be efficiently transported between your offices through the internet. And then there's other areas or applications where it's more appropriate for it to be done through that private circuit. And SD-WAN offers the ability to more cost effectively ensure that you can take advantage of those bandwidth offerings and ensure that you are cost effectively sharing the load across all of your different offices. That's the general premise. There's a little bit more to SD-WAN than that. But so enterprises need bandwidth, and they want to know that what they're paying for is what they actually are getting and that there's value. new kids on the block. Let me explain what I mean by that. So Google, Facebook, Amazon, Microsoft, they are all very much focused on essentially being telco providers. So they have spent, millions upon millions of dollars to build out infrastructure, all over the globe in order to provide cloud services to their enterprise customers. So it's very interesting, and for traditional telco carriers, it's very threatening to imagine that now I'm competing with Facebook or competing with Google for services that are traditional services that I provide to my customers. So it's a very interesting time in terms of the challenges that the telecommunications industry is dealing with. Okay, so how can blockchain help? Okay, so earlier I was talking about, what a distributed ledger is. And again, because of its history, people tend to think of it from an accounting standpoint or financial application standpoint. But in the world of networking and in telecommunications, we also have the need to have a distributed database. It's very, very important, whether you're talking about the internet or whether you're talking about a private network that's built. You need to have routers that can share information amongst each other about the reliability of the network, whether or not there's convergence. If you're, obviously you would need what's called a routing protocol, so that there's awareness from each of those routers, or we can call them nodes, of how to, transmit traffic from one location to another. Incredibly important. And so for me, when I began to understand the value of blockchain and a distributed ledger, immediately it made sense to me to say, hey, well, in networking, we have the same requirement of having a decentralized distributed ledger. Why can't we use the blockchain for that? And we'll talk more about that. This is really one of the key important areas that can be very beneficial for telecommunications. There's more, including just basic efficiency in routing, efficiency in data transport. There's also security. So for those that are aware, within blockchain, there is cryptography that's used. There's SHA-256 cryptography. And to date, it has never been hacked. One of the things that's interesting to know is that, of course, within the world of cryptocurrency or within certain realms within blockchain, there have been security breaches, but these have never been related to the underlying technology itself. It has always been ancillary functions or human interaction or mistakes that have caused these breaches, but the actual cryptography itself has never been broken or penetrated. So blockchain can also help telecommunications by creating a trustless framework for bandwidth on demand. So earlier I was talking about what is it that enterprises really need, and what they need is the ability to know that the bandwidth that they're paying for has value. So this might not be a bad place to talk about, a niche example, but just to make the point. So I think I've helped to describe how bandwidth is actually sold on a lease basis. When I was the global program manager for Deutsche Bank, if my analyst came to me and said, hey, I need a gig of bandwidth between London and New York, I would go to a carrier and I would learn what the pricing was for the lowest latency circuit. This is a transoceanic circuit from UK to New York. And in order to get the best pricing, we would negotiate a 3-year term. So now, if it turned out that my analyst overestimated, we would be paying for that 3-year term for 1 gig of bandwidth that we're not using, that we don't need. If on the other hand, we underestimated how much was needed, we'd have to provision a new circuit. And here's something that's just kind of funny to share, because I think it's shocking to most people that aren't involved in telecommunications. The turnaround time for that new circuit is typically 60 to 90 days. So, in the world of high frequency trading, that is just ridiculous. There's no way you're going to be able to support your customer if it's going to take 3 months in order to build up a circuit between 2 locations. And, with blockchain, there's the promise or the ability to support faster provisioning time, and ultimately the ability to actually, I'm speaking a little bit about what OpenCTNet is working on or has developed specifically, and I'll just talk about it because it is part of the future vision of how blockchain can help telecommunications, and that's this. By having switches that can take predictive measures of applications that can on the fly provision just the right amount of bandwidth that's needed, they can turn up lambdas, and then based on the needs of that application, they can turn them down. And so now we have a new model through which bandwidth can be sold, and this is bandwidth on demand. This is allowing an enterprise the ability to enter into a contract with a carrier where they can literally not guess how much bandwidth they have and inefficiently overpay, but actually pay for the bandwidth that they use. And this can involve smart contracts, once again, to immediately recognize that a triggered activity has resulted in the creation of a new circuit, and then immediately billing the customer for that. And then as soon as that bandwidth is no longer required, issuing a new aspect of that smart contract to turn down that circuit and to disable the billing for that circuit that was just provisioned. So it's all very exciting things, and this kind of efficiency is really going to carry forward value for global enterprise customers, and it's going to really allow them to appreciate those carriers that can adopt this solution. So number 4, creating a fair marketplace for bandwidth providers. So again, all of the telco carriers in the world have to interoperate with each other, and they all have their specific localized pricing. But in order to support their partners, they need to have some construct or framework through which they can offer bandwidth and support the traffic that is being received as well as what's being sent. And blockchain has the ability of creating a framework through which they can fairly transact and share costs in real time and in a way that has value. Today, a lot of this information is hidden even from these partners, and there's a lot of guesswork that goes on in establishing pricing. And while it has worked in the past, with all of the disintermediation that's happening, with the competition that's being realized from Microsoft, Google, Facebook, for the right folks, this will be incredibly beneficial because it's, again, providing real value to customers. So finally, I'm going to talk about what OpenCTNet is doing here in Kazakhstan. We are actively developing and deploying blockchain-based telco applications for large enterprise customers. Currently, we're focused on deploying something that we call blockchain as a transport. Very fascinating. I'll touch on it just a little bit. And so today we are offering BAT circuits, blockchain as a transport circuits, and a product that we call BAT VPN as well. So I'm not going to go through all of the details on this slide, but essentially what makes blockchain as a transport so transformative is that we are able to leverage the public internet as the underlying infrastructure in order to very cost effectively provide services, much like Zoom or WhatsApp or any of the very cool consumer services or applications that we all use. But now, by leveraging that same infrastructure, we're able to use blockchain as and it's very funny for those that are truly understanding blockchain technology. We are using blockchain as a centralized platform through which we can share information across nodes throughout the internet in order to ensure the ability for data to be securely transported. So I'm not sure everyone will understand what that means, but I'll just explain it very simply by stating that the internet itself is not thought of typically as being either efficient in terms of data transport or secure enough to support certain enterprise applications and even certain protocols. So multicast, for example, is a protocol that inherently would require private circuits to be used because you need to know at the very beginning exactly how that data is being transported across the network. So the internet, there's constant variances and factors as to how data will be transported, which leads to some very cool positive things, but from an application standpoint can be challenging. Well, what OpenCTNet is doing is we actually are using the blockchain to ensure that we can provide that centralized authority of information across the nodes in a network so that they know exactly how to route and can now efficiently use the internet. So that's kind of exciting. And definitely what I would say is a great starting point or a starting block in how blockchain can support telecommunications. And further to that, I'd like to state that, this is also a new way in which blockchain is being leveraged. I would almost call it a third wave. So, right now there's still a lot of applications that are financially based, or there's a lot of services that are supporting different industries, but focusing again on blockchain as that distributed ledger or accounting authority. Whereas what we're looking at is using that distributed ledger for an entirely different purpose, and that's securing the internet, securing data transport, and allowing for more efficient routing of data. Okay, so that is what I wanted to cover today in terms of blockchain's use in telecommunications. And now I would love to, open it up to questions to anyone on any topic related to this.
Окей. Я извиняюсь, у кого-то имеются какие-либо вопросы? Вы можете написать в чат.
So while we're waiting for questions to come in,
Yeah.
I'll just state again that, what we're talking about is very new, very groundbreaking. And it really is exciting to talk to engineers within telecommunications who recognize the concept of how this distributed ledger can be used for more efficient routing. We're very proud to be, trailblazers in this endeavor. But, I suspect that, for those that are very excited about blockchain, that there will be a lot of excitement around this new approach or this aspect of how a distributed ledger can be leveraged as opposed to, just basic accounting or identity management as what has been thought of in the past as the route for different industries to take advantage of blockchain. Well, great. I mean, if there are no questions, that's fine. Super excited. I'm here at Astana Hub.
Thank you too.
Yes, exactly. And if at any time anyone would like to learn more about, what we're doing or learn more about how this product is being used or available and what we're developing next, we have other applications that we're working on that we're very excited as well. Excellent. Well, thank you very much, everyone, for your time. And, we look forward to having another one of these, and we can delve even deeper if there's interest on the technical side. So thank you very much.
Okay, thank you too. Thank you for the interesting masterclass.
Excellent. Thank you.
Thank you.